Alright, the triangle inequality theorem. It states that the sum of the lengths of any two sides of a triangle must be greater than the length of the third side. The sum of the lengths of any two sides of a triangle must be greater than the length of the third side. So if you draw a triangle on your paper and label it PQR, the theorem would mean that side PQ plus side QR must be greater than side PR, and side QR plus side PR must be greater than side PQ, and side PR plus side PQ must be greater than side QR. All three of those inequalities must be true in order for the side lengths to form a triangle. Now here's kind of another little version of the triangle inequality theorem. And it says that the range of values for the third side of a triangle must be between the sum and difference of the two shortest / given sides. The range of values for the third side of a triangle must be between the sum and difference of the two shortest / given sides. Meaning, if they give you three sides, it's the sum and the difference of the two shortest. If they only give you two sides, then the range of values for the third is going to be between the sum and difference of the two numbers that are given. So if you look at example 1 on page 364, you are asked, is it possible to form a triangle with the given lengths? Alright, you get an 8, a 15, and a 17. There's two ways to do this problem. We're going to do the book way, or the triangle inequality theorem way first. The triangle inequality theorem said that the sum of any two sides must be greater than the third side. So if you take 8 plus 15, is it greater than 17? Yes. Is 15 plus 17 greater than 8? Yes. And is 8 plus 17 greater than 15? It is. So is it possible to form a triangle with the given lengths, 8, 15, and 17? Yes, it is. Now, that's how you can answer that question using the triangle inequality theorem. The other way that you can answer this question is to take the two shortest sides. The two shortest sides in this case are 8 and 15. If you add those together, 8 plus 15 equals 23. If you take the two shortest sides and subtract them, take 15 minus 8, and that equals 7. What that means is that the range of values for the third side of a triangle with sides 8 and 15 is between 7 and 23. So is this third side between 7 and 23? 17 is between 7 and 23. So yes, those lengths form a triangle. You can use either method. I think this method is faster once you get used to it. Okay? So let's try the lengths 6, 8, and 14. I just take the 6 plus the 8. That equals 14. The 8 minus the 6 is equal to 2. So the range of values for the third side of this triangle is between 2 and 14. Is this third side, which is 14, between 2 and 14? It's not, is it? It's got to be less than 14 and greater than 2. So this would be a no. Those lengths would not form a triangle. In that case, the third side is too long. $15, 16, and 30. Again, you take the two shortest sides and add them together. So 15 plus 16 is equal to 31. 16 minus 15 is equal to 1. So the range of values for the third side, 1 is going to be less than x, which is less than 31. The third side of that triangle has to be greater than 1 or less than 31. So does this 30 meet that criteria? Yes, so these would form a triangle. Let's try one more. How about a 3, a 7, and 12? Again, you take your two shortest sides and take 3 plus 7, and that's equal to 10. Then take your 7 minus your 3, and that equals 4. The third side of this triangle must be greater than 4 and less than 10. Does 12 meet that criteria? It does not. Alright, so no. Those lengths would not form a triangle. Alright, does anybody have any questions on that theorem? Pretty straightforward, right? Okay. Alright, your assignment for today is on page 366. Problems 1 through 4. 6 through 17. And 20 and 21. Please be sure that you're checking the odd answers in the back of the book.